Hello Year 10, I hope this PowerPoint finds you all safe and well. This is our first lesson back in January and we're going to be talking about conservation of mass. Now you should have done about balancing equations in Year 9, but a lot of things have happened since then and it was a very long time ago, so if you really understand it then great, just do all the practice questions. If you fly through them then amazing, but I know some of you will still need some more help with this, so that's what we're going to do today. So first of all, in your books, I want you to write down the date and title and LO. So the date today should be the 5th of January, but you might be doing this on a different day, which is fine. Write the correct date that you are currently on. And then I want you to try the starter questions. Now the starter questions, I will go through the answers in 5 seconds. So if you want to pause the video here and try it, and then I will say the answers in 5 seconds from now. Okay, the answers. So the answer to number 1, the atomic number in this case is the one at the bottom, but on different periodic tables, they might be the other way around. Okay, so the atomic number is the smaller one. In this case, it is 3. Okay, so the atomic number of lithium is 3. The atomic mass, that's the bigger number at the top, that is protons plus neutrons, so it's going to be the bigger one. So if atomic number is just protons, then protons plus neutrons will be a bigger number. Okay, so the atomic mass of lithium is 7. How many protons does it have? So that is the atomic number, so that is again 3. How many electrons does it have? So protons are positive, electrons are negative. They want to be neutral overall. So if they've got 3 positives, they want 3 negatives as well. So lithium has 3 electrons. How many neutrons does lithium have? So you do the big number, take away the little number. So the answer would be 4 neutrons. Okay, so we've got atomic mass, which is protons plus neutrons. If you take away the number of protons that we have, you are left with 4, and that is the number of neutrons. Now the electronic configuration of lithium, this is what we did before with the shells. Okay, so you remember it goes 2, 8, 8, 2. Okay, so in the first shell we've got a maximum of 2 electrons. So we have 2 in the first shell, and then because we have 3 electrons overall, we've only got 1 left over for the next shell. So it's 2, 1. If you wanted to draw a picture, it would look like that, but probably a little bit neater. Okay, conservation of mass. So the definition of the conservation of mass is that matter cannot be created or destroyed. It can only be rearranged. Okay, so if you have an equation with copper on the reactant side, it's not going to suddenly disappear on the product side. Copper needs to be there somewhere still, okay? So matter can't be created or destroyed, it can only be rearranged. So I want you to write that down because that's really important. Okay, so conservation of mass, it can't be created or destroyed. It can only be rearranged. Right, the rules of balancing equations. So using the conservation of mass principle, we know that we need the same amount of a product on the same amount of a chemical on one side of the reaction as the other side of the reaction. Okay, so these are the rules. You can only change the number before the molecular formula. So there are big numbers before a molecular formula. So for example, this H2O here, if I had let me get a different colored pen. If I had a number 2 in front of it, that would mean there are two H2Os, okay? So 2 molecules of water. And that number 2 there is the only one we can change. We can't change this little 2 here because that is part of the formula. The big 2 at the front is the one that we can change, okay? Same as if it was any number, so if it was 4, that just means we've got 4 H2O molecules. Okay, so you can only change the numbers before the formula. You can't change the subscript number, so subscript means small, like this little 2 here. Okay, so subscript means small. You can't change that because that will change the molecule and you'll have something different. You won't have water anymore. If there is no number in front of it, then it means 1. Okay, so we've got H2O written by itself. That means that there is an invisible 1 before it. So that there is 1 H2O molecule and there is 1 oxygen, but we don't bother writing the 1. So to calculate the number of atoms, you multiply the number before the subscript. Okay, so if we have 3 waters, then it means you do 3 times 2 to tell you how many hydrogens you have. So that would mean we have 6 hydrogen atoms, and then 3 times the invisible 1, which is 3, so we would have 3 oxygen atoms. So those are the rules of balancing equations. Okay, and now I'm going to go through some examples with you. Right, first set of examples. So we have 2 equations here, and we are going to go through the first one first. So what I would do for practice is I would do a little table like this. So you write reactants on one side and products on the other. Remember, reactants are always before the arrow, so on the left, and products are always after the arrow, so on the right. So in this example, we will do copper first. So in the first example, we have 1 copper here. There is no number in front of it, there's no number after it, so that means we just got 1. Okay, and then on the product side, there is just 1 copper. Again, we've got no number before, no number after. We do have a number 4 here, but it's not immediately after the copper. So that little number 4 is just talking about oxygen. Okay, so we have 1 copper on one side, 1 copper on the other. Next, we will do the hydrogen. So hydrogen, we have a little 2 after it, which means there are 2 hydrogens on the reactant side, and the same with the product side. Next one is sulfur. So again, we don't have a little number immediately after the sulfur, so that means there's just 1 on this side, and then the same as the products, just 1. And our very last element is oxygen. We've got a little 4 after it on this side and on the product side. So there is 4 and 4, which means this equation that we have here is already balanced. We don't need to do anything to it. Okay, so sometimes you will have questions where it says just to leave it if it doesn't need balancing. Okay, so you can explain that it is balanced already and you don't need to do anything to it. Right, example number 2. So we are going to draw our little table again. So reactants and products. And first of all, we are going to do calcium. Okay, so we've got calcium on the reactant side. It doesn't have any numbers before or after it, so we've got 1. And then calcium on the product side, exactly the same. Okay, and then we have oxygen. So on the reactant side, it's got a little 2 after it, which means there are 2 oxygens. On the product side, it doesn't have any numbers before or after it, so that means we've only got 1. So this is where we need to start adding in our coefficients, okay, or the big numbers in front of the molecules. So this molecule in the product, we would put a 2 in front of it, and that times is the whole thing by 2. So that means we now have 2 oxygen on the product side. Okay, so now our products and our reactants match for the oxygens, but now we've got another problem, which is the calcium, because it means it has timed the calcium by 2 as well. So it's times the whole thing. So now we have 2 on the product side and only 1 on the reactant side. So what we need to do now is we need to put a 2 in front of the reactant side of calcium. And now we have 2 calciums on the reactant side, 2 on the product side, 2 oxygens on the reactant side, and 2 on the product side, which means it is now balanced. Okay, so now I want you to try for yourself. I have attached a worksheet on Show My Homework, or I think it's called Satchel 1 now, sorry. So I've attached a worksheet on Satchel 1. I don't want you to do the hard one at the bottom, so there's easy, medium and hard. I only want you to do the easy and medium ones, please, and the answers are attached for you. And then if you want any extra practice, you can use this page here to go onto a website, which is really good for giving you examples of balancing equations. Okay, so use this information on the screen if you want extra practice, and I want you to do the worksheet that I have attached on Show My Homework, please. And that is the end of today's lesson. So stay safe and take care, and I will see you soon.